Hey guys, today we're going to talk about range sum of BST binary search tree. Given the root node of a binary search tree, return the sum of values of all nodes with values between L and R inclusive. The binary search tree is guaranteed to have unique values. So what do we know about a binary search tree is that anything at the root is going to be greater than all of its values on its left child, and anything it'll be less than all the values to its right child. Okay? So let's look at the examples to see how we can kind of imagine this problem. So given binary search tree, find all the values between 7 and 15 inclusive and add them together. So in this case we have 7, 15, and 10, and together they all sum to 32. In this case we have L is 6 and R is 10, so we have to find all the values between 6 and 10 inclusive, which happens to be 10, 7, and 6, which is sums to 23. Now we can do a linear search through the binary search tree and look at every single node and sum up the ones that are between these ranges, and we'll get our answer. However, that'll be linear time in that we'll have to visit every node in the tree. We're not taking advantage of the properties of the binary search tree. So what we want to do is consider the root, right? If the root is less than the minimum in the range, the L, then we know that all the values that could possibly sum up to be in between this range are going to be to the right. And same thing in the converse. If the root value is greater than the right limit, R, then all the values that we could possibly sum for this problem are going to be in the left child. And so basically what we want to do in the solution is do that, trying to narrow down our search area, and then eventually we'll have searched all the possible ones that fall between these ranges, and we'll have our answer. Okay? Cool. And so whenever there's a tree, I lean towards writing a recursive solution. So usually I just keep the wrapper function of the original question, and I'll just return a helper saying self.getRangeSum BST, right? It's going to take the root L R and our current sum, which is 0, to start off. So let's define this method, getRangeSum BST, self root L R current sum. Right, so if there's no root, right, let's return our current sum. So if it works for an empty root and it works for our recursive base case. Otherwise, we want to return the current sum after we do some operations down here. And the operations we talked about were consider the root value, see if that should be added, and then see which side of the tree we should kind of recurse on, or maybe both. So here we go. If root.val is less than L, right, we want to recurse on root dot. So if the value is less than L, right, the value in our root is less than our leftmost thing, it means any possible value that we want to sum is going to be in the right child. So root dot right LR and then current sum, because we haven't found anything that fits yet. Else, if the root.val is greater than or equal to L and root.val is less than or equal to R, meaning it's within our range, right? We want the current sum to be equal to our original sum plus this new root.val. And then we want to recurse on both children because we don't know if it's where this root.val actually stands within this range. So we'll do the same thing. We'll do this. Oops. We'll copy this. Do left here, current sum, okay? And our last option is if our root.val is greater than R, that meaning our current value is greater than our max limit, so we want to see check all the children in our left side. So let's just copy this. Okay, cool. So this looks solid to me. We might need to look at what this returns. So I think what we'll need to do here is assign the output of these recursive calls to a variable. That way, eventually, when we get out of this if statement, this conditional statement, we'll return the current sum of them after all the recursive operations have finished. So let's walk through this. Let's walk through this with an example. So here we have 5, 4, 9. This has 2. This is empty, and this has 7 as a left child, and 10 as a right child. And we want to find L is, let's say, 3, and R is 8, right? So we're going to start at 5. We're going to say, okay, we have a root. If our value is between the left L and R, which it is, add to 5 to our current sum, and then recurse on left and right. So 5 is our current sum. Let's go through the recurse left. 4 is between 3 and 8. So now we add 4 to this list. Then we recurse on the left child and the right child. So left child is 2. So we'll get this value, and this will recurse on the right child of that, which is nothing. So eventually we'll return current sum, which is 5 plus 4. Then we'll do the same thing on the other side and eventually pop back up the stack for our recursive stack, and we'll get back our answer. So let's run this and see actually how it works. So let's see if it does work. Give me something. Cool, we got 32. So let's run it on some edge cases. Empty array, always a good one. Cool. And let's just submit this and see how it goes. Nice. Well done, guys. So what we learned here is binary search tree principles, recursion, and keeping track of our previous work with an extra parameter to our recursive function. Thank you.